Alrighty, so this is the last video for chapter 12, and what I'm going to do in this video is put together the simulations that we went over in videos 2, 3, and 4 and put everything into one worksheet so that we can simulate the expected profit for the Portacom problem. Alright, I know that there are a few other simulations in the book. I'm not concerned about them. One's an inventory simulation and then one's a waiting line simulation. For this particular class, I'm going to ignore those because financial planners don't need to simulate inventory problems or waiting line problems, all right? Unless you're a really busy financial planner and you have a large waiting room, then you might need to. But other than that, I don't think you need to worry about it. Okay, so with that said, let's put all the pieces together for the Portacom problem. So this is on page 598. Your author goes over everything. I just want to show it to you. You can use your book as a reference. So the first thing that you want to do when you are setting up these worksheets, and you want to keep them as flexible as possible. So what that means is instead of embedding a lot of things in the cells, I'm going to keep everything out in what we call input cells. So for example, price 249. So when I calculate my profit, I'm going to reference this cell instead of putting 249 in my profit function. That way, if price ever changes, I just change it here, and then it changes throughout all of my trials. And then same thing here for my admin costs and advertising. Admin, I think was 400, yep, 400,000. And this was 600. All right. Okay, so now what I need to do is start thinking about my simulations. Well, I know for my labor simulation, I need that VLOOKUP table. So I'm going to put that in next. So if you remember from that video when we did that, you're going to need a table with two columns. One had the lower bound of my intervals, and then the other had the costs. And my lower bounds were 0, 0.1, 0.3, 0.7, and 0.9. And then my cost started at 43 and then went up by $1. Okay, so that's my VLOOKUP table for my labor costs. And then I need to create some inputs for my continuous uniform distribution for my parts, and then my normal distribution for my demand. So I'll say here my uniform, oh my gosh, distribution for parts. And so here I need my lower bound and my upper bound. And if you remember, that was 80 and 100. And then I need my normal distribution for demand. And that I needed a mean and a standard deviation. And the mean was 15,000 and 4,500. So here I've got all these input cells. So now I can just reference all these cells. And if something changes down the road, I just change this and everything else will update. And I'll show you that as soon as I'm done. Okay, so with that said, now I'm in a position to start creating my trials. So trials, and I need to simulate my labor costs, my parts cost, my demand, and then of course my profit. All right, so here's trial one. So if you think back to that video, we're going to use the VLOOKUP table to simulate our labor. So I'll get that VLOOKUP function, hit OK. And again, so the VLOOKUP value, just type in the RAND function. And remember to do the open and close parentheses. That is the way you have to do, whenever you use the RAND function, it's always RAND, open parentheses, close parentheses. Oddly enough, if you forget those, you're going to get an error message in Excel. All right, and then I just highlight my table array. So there it is. My column index number, so I want Excel to find the lookup value in the first column and then give me the corresponding row in the second column. So that's a 2. Oh. Just to be complete, okay, sorry, just to be complete, the lookup range, you can omit this, but I usually type in true, just so that I know what I've done. Okay, so there is my VLOOKUP. Now what I want to do is I want to anchor my table so that when I copy this down, because I need 500 trials, so I want to anchor that table so that when I copy it down, the table never moves. Okay, now I'm on to my parts. So this comes from the last video. We want to use that function that I was telling you about or showed you. So that was, right, the lower bound of my continuous uniform distribution plus the RAND function times the difference between the upper bound and the lower bound. Okay, and so here would be my first simulation of the price for these parts. Now the same thing, I need to go in here and anchor the lower bound. I never want that cell to change. And then anchor the upper bound and then again the lower bound. All right, so that again, when I copy it, those aren't going to change. And then I've got my demand. Well, that followed the normal distribution. So I need the norm.inverse function to simulate my demand. Again, my probability is just the RAND function, open and close parentheses. The mean, highlight this cell, and then highlight the standard deviation and hit OK. And then the same thing, you need to go in here and anchor the mean and the standard deviation. Okay, and then finally my profit. Well, profit is just price minus my per unit cost of labor and parts times the demand, right? So that's going to give me my variable profit. And then I need to subtract from that my fixed expenses. Okay, so to do that, profit is just price minus labor costs minus parts costs. All of that is multiplied by demand, okay? And then I like to put a parentheses around this because next I need to subtract the sum of my fixed costs. And presto, there's the profit. Now I need to do some anchoring here. I need to anchor in the price. Do not anchor labor, parts, or demand, right? I want those to copy down or to move down when I copy so that I can get the labor cost for trial 2, parts cost for trial 2, demand for trial 2. But I do need to anchor in my fixed costs because those won't change. And there you go. So now all we need to do is copy this down. So the easiest way to do this is for trials, just make this a formula, right? The second trial, this equals this number plus 1. And then I'm just going to copy these down one row. And then I'm going to highlight everything, copy, and then go down. So I got to go down about 530 rows. Okay, a little too far. That's all right. Let's call it here. So see how close I came. Ooh, boy, I was off. No problemo. So just go up here. Just wanted the 500 trials. It doesn't, you could go to 519, doesn't matter. We've got so many trials, numbers aren't going to change. Okay. All right, so there you go. I have now simulated 500 trials of the Portacom profit model, right? So what's going to happen here, you know, with the distribution for parts, labor, and the normal, the demand? Well, the reason we do this is to calculate some statistics, and by far the most important is the mean. Now, this goes back to the very first video of chapter 12, and that's why I put this video, that video in here, because the whole point of these simulations is to calculate this mean. So this mean is going to be the sample mean, right? I have 500 samples. Those are my trials. And so if I calculate the mean of those 500 trials, that is going to be my sample mean. And the whole point of that first video was to say, look, from the central limit theorem, we know that the sample mean is normally distributed, one. More importantly, we know that the expected value of the sample mean is equal to the true population mean. In other words, the sample mean is our best estimate of the true population mean. So for example, let me take the average of these trials. Thought I had it in there. Average. Highlight all of my profits. Okay, sorry. So this mean is our best estimate of the true but unknown population mean. What that means is that for Porticom, this is the profit you would expect to get. Okay, that's why we do this. So this is telling Porticom's managers, look, you're roughly going to make about $718,000. Okay, now with that, of course, you're going to have a standard deviation. So how much do these profit numbers deviate? So to calculate that, use your standard deviation function, and you need to use the .s version, right? Because this is a sample, it is not the population. So you want to use stdev.s and then just highlight your profits. So this tells me that my profits actually have quite a bit of variation in them, right? One standard deviation is 526,000. So, if you think about that, that's, quite a bit, right? Your profits, if you're down one standard deviation, your profits are going to fall 526. Now, on the positive side, if you're one standard deviation above the mean, then your profits are going to go up 526,000. So that's not bad. All right, the other thing we can do is calculate our minimum, and maximum values for our profit. So to calculate the minimum, just get the min function. There it is. So what's the smallest profit we incurred? About $1 million. Okay, fair enough. And then what's the maximum profit our simulations gave us? Well, to find that, use the max function. So again, just highlight your profits. Oh, that's nice. 2 million. Okay, I like that. All right. And then finally, and this is all in your book, but then a nice thing to do is to calculate the number of losses. Right? So this is going to tell us of the 500 simulations, how many of them had a negative profit. So to calculate this, you're going to use the COUNTIF function. So COUNTIF, and this has two arguments. First is the range. Well, we want to count the profits. Okay, so highlight that. And then the criteria is any profit less than 0. But bear with me. So if I just type in the less than symbol and 0, I don't get anything, right? And I'm not sure really why this is happening. But for whatever reason, when it comes to the COUNTIF function, and this could be true of other functions, I'm just aware of it with the COUNTIF. When you have these criteria, you have to put the double quotes around your criteria. So hit double quotes, less than 0, and double quotes again. And now look, this formula result is 35. So for putting in those double quotes allows the COUNTIF function to actually count everything, right? So what this is telling me is that there are 48 trials where the profit is less than 0. And then once I know the number of losses, I can calculate the percent of loss. And so this idea is, well, if there are 56 trials that have a loss out of 500, that's going to give me the percent of times this company could expect to incur a loss. And so that's right around 7.6%. Okay, well, these are the usual metrics that we calculate when we do this stuff, right? The most important one for sure is the mean. And then this is also a nice one, right? Because what this is telling me is that there's, say an 8% chance that Porticom could incur a loss. Well, that means then that there's a 92% chance that they're going to make a positive profit. So the odds are pretty good there. Of course, the min and max are just naturals, right? It is possible, given these 500 trials, that they could lose 1.5 million, but it's also possible that they could earn 2.6 million, right? What you would expect them to earn is somewhere around 782,000. So the idea usually goes is these firms set like a minimum profit that they want to achieve. So let's say Porticom says, we want to make at least 500,000. Well, since your expected profit is above 500,000, this would be a worthy project for Porticom to engage in. All right. And then lastly, just a few, let me back out. So, okay. So, I started this by saying, look, you want to keep this as flexible as possible. Well, why? Well, let's say that management comes back and says, oh, let's increase the price to 251. Well, all you have to do is change this to 251 and everything is going to update. So let me just scroll down a bit. So I haven't hit enter yet, but watch, when I hit enter, everything is going to change, right? All of these simulations were redone. And now my profit went up a little bit. Standard deviation stayed about the same. The minimum came up, maximum came up a little bit, and the percent of losses actually went up a little bit, which is okay. It's a simulation, so no big deal. But you can do the same thing here for the distribution of the parts. Maybe later on you realize that the upper bound for the parts cost is only $95. So once again, let me just scroll down a little bit. So once I hit enter, everything, right? Everything is going to change. Okay. Same thing with the demand. So maybe they realize that the mean of the demand is actually, say, 16,000. So all you do is hit 16,000, hit enter, everything changes, and there's your new summary statistics. All right. Same thing here. Maybe your cost here for your intervals changes. So, maybe it starts at 41, 42, 43, 44, 45. Again, presto, right? Everything changes. That's what's so nice about keeping these models flexible. And in fact, you can actually do it here. Let's say you fire a couple of your admin. So let's cut that in half. Right? Everything changes. So that's what I'm trying to get at when I say keep these as flexible as possible, because then you just change it, a cell or two, and everything is going to change for you. Now, one last thing I want to talk about is as follows. So when we set up our trials, we had a RAND function in the labor. We had a RAND function in parts and a RAND function in demand. That's the way you want to do these. Because what that is doing, if you guys go back, think back to your stats class, that means that the simulation for labor is independent of the simulation for parts, which are then independent from the simulation of demand, because I am randomly generating 3 different random variables for labor, parts, and demand. You never ever want to have like a single, so my RAND, my RAND function, say. You never ever want to do something like this, RAND, right? And then link labor to this, and then link parts to this, and then link demand to this. Never ever do that, because that destroys the independence between labor, parts, and demand. Right now, they're all referencing the same RAND function. okay? And so they're all going to be tied together in a sense, right? So never do that. You lose the independence. So let's just get rid of that. Okay, well, there you go. There is the complete model. Setting up this way makes changes super, super easy. Yeah, I guess that's it. You know, pretty cool stuff. I think it's pretty cool, but that's why I'm a nerdy college professor. But at any rate, I certainly hope this helps. And just to give you an idea of what we're going to be doing next, we're going to be taking some of these. So next week, we're going to take this notion of simulations and just apply it to financial planning problems. So we're going to simulate expected stock returns. You can simulate different cases, you know, like investors withdrawing, right? So you can actually simulate, you know, an investor starts off with $1 million, and let's say their withdrawal follows a uniform distribution over 10 years. What can you expect there, you know, in 10 years, how much is their money going to go down to? Stuff like that. You can also do that, you know, you start off with $1 million. Let's say your earnings or your expected returns on that $1 million, let's say they follow a normal distribution, and then again, your withdrawals follow some other distribution. Well, you can simulate that and try to get at, you know, where do you think this client is going to end up in 5, 10 years or whatever. So that's the stuff that we're going to apply this simulation to, all right? This is just kind of a warm-up, get you used to simulations, what's going on, how to do it. Next week, we'll apply all of this to specific financial planning problems. Okay, well, that's it for this last video. I've gone on for 22 minutes, so hopefully no one has fallen asleep.